So we're here to talk through this interesting Skyscrapers puzzle by Collyer. It has a theme which involves every row and every column having one of its two sides clued. But those clues are rather middle-sized numbers, so there are no 1s, 2s, or 6s, or 7s to really drive things very fast. Clues like 4s tend to not tell you too much in a puzzle like this, and you get a whole slew of 4s. And so that ends up leading to some new emergent properties, sort of a kind of different way this puzzle solves, which is pretty cool and definitely made this a puzzle we wanted to highlight on the website. You can start this puzzle the way a lot of people start any Skyscrapers puzzle, which is to think about just the largest buildings. When we have 4 clues blocking off these rows, each of which can only have its 7 in the rightmost 4 columns, we actually have set the exact positions of 7s in those columns to be, rows 1, 3, 5, 7 are going to be in B16 cells somehow. Rows 2, 4, 6 are going to be on the left side in the left 3most columns. Now if we actually use the intersecting column clues, we'll see that in the top rows, the only 2 spots a 7 can sit because we can't put a 7 near these 2 cells, or these 2 clues are here. So those are 7s, or those are 7s. We similarly get a set of options down here. If we look at where the 7s are in these columns for these clues, the top one actually only has 1 spot. First digit most people put in the grid is that 7. And then we have a set of either or choices right here. And that's where the most typical starting point will get you, but this is when you'll want to transition to the unique kinds of logic that come about in this puzzle. And what I'm going to do is introduce a notation which is to circle cells that are small, and by small I'm going to mean a digit from 1 to 4. And I'm going to put a square around cells that I know are large, and large will mean a digit from 5 to 7. In this case, like the cell I'm marking now, I actually know the 7 doesn't sit in it, so this is a 5 or a 6. But this cell is a 5, 6, 7. This cell can be a 5, 6, 7. And the reason I know that these cells are small is that they're sitting right next to a clue that's 4 or larger. It actually turns out I've marked this wrong. Next to a 5, your largest potential first building is a 3, so we can actually write a smaller range, a 1 to 3 range in that cell. Down in the bottom row is where this becomes pretty important pretty fast, is we can mark the 3rd, 5th, and 7th cells in that row as large. So 5, 6 here, a 5, 6, 7 potentially there, a 5, 6, 7 potentially there. In this column, we get a similar 1 to 4 set. This cell is a 5 or 6. There's a overpowered logical step you can do here. You don't actually, I think, have to solve the puzzle. You might say this could be a 5, 6, 7, but there's a kind of pattern. Notice the 3 will see this building in the first cell, and then needs to see just 2 of the buildings in the set. When you have something like this set up with the smallest 2 of a 3-digit range, a 6 is impossible in the cell because a 6 here means a 5 there, means a 7 here, means 4 total buildings. So you can actually say the middle cell is the smallest and largest of 3 options, but not the second of those 3 options. So 5, 7 is what's allowed there, 5, 6, 7 in this cell. The top row is where actually this logic has its most interesting piece and what will get you forward in the puzzle. And that's that while these 3 cells are cleanly marked as small, you may think that this cell doesn't fit the same billing. But once we actually have this bottommost cell being a large building, a 5 or 6, the initial options, which are like 1 to 5 for this space, the 5 now becomes impossible. If this were a 5, the 6 is hidden behind the 7, whichever of these 2 cells it sits in. We just can't fulfill that clue. So the 3 actually also is a small building. And we can sort of mark with squares the rest of this row. But you should recognize if the first building is seen, this large building is seen, and we need to get to 4 total buildings seen. This has to be a 5, this has to be a 6, this has to be a 7, so we get 4 buildings seen. I'll mark off that clue now that we've satisfied it. That places those digits. There's a sort of follow-on logical step we're going to use a fair amount in this puzzle as well. Once we know that we're hiding a large building behind a 7, we can reduce this range. So on this 1 to 4 clue, it's now effectively 1 to 3. If this were 4, 5, 6, 7, we couldn't fill this cell, so this has to be 3, 4, 5, 5, 6, but one of the large buildings is missing. The largest this can start is now 3. Same with this clue here, 5 or 6 is hidden behind the 7, so if we start at 4, we can't get to 4 total buildings seen because a 5 or 6 is hidden. We can start at 3 though, so we'll put in a 3 right now. We're going to transition back to standard skyscraper thinking this moment and think about some 6s, the second largest buildings. They're going to be pretty constrained right off of these clues, and that's because 2 cells in to a clue like a 4 or 5, you can't have a 6. So if I look in this row, a 6 can't sit in the cell already. We know that it can't sit here. Can't sit 3 in from a 5. It can't sit here, which is 2 in from a 4. Can't sit here, which is 2 in from a 4. In this 6th row, 6s can only sit in the first and third columns. And I'll have you remember a few minutes ago we said that a 7 could only sit in the first or third columns. And so we've actually identified a pair of cells in this grid, which are a 6 and 7. That actually means that the 5 doesn't have a lot of spots it can sit. We already have a 5 in this column, so the 5 has to be somewhere over to the right here. Normally for a 5 clue, the 5 would have to be the 3rd or 4th building seen. It can't be sooner than that, so this can't be a 5. If it were a 5, we can't get as large as this. So a 5 is in one of these 2 cells, but we've marked a 6 up here. 6 is hidden. If 5 were seen right here, it would be the largest remaining building before 7, so we'd only get to a count of 3. So we know this has to be the 5. And we can follow that up further. If this is a 5, both the 6 and 7 are seen, so we can get an order for these 2 clues. 6, 7, that gets this set of 7. We knew this was a large building, so its only now option is a 5. This had a 5, 6 option, but we already told you that a 6 isn't possible in the middle one. So we actually get this order here. We fulfilled that clue. This clue up top obviously can't start as a 4. What's actually more interesting is these are strictly increasing, and it looks like we can do a 1, 2, 2, 3, 3, 4 group, sort of increasing in that direction. What I'm seeing is actually there's a good opportunity still now to just think about large digits, particularly the digit 6. Let me clean up these 2 cells. Column 2 needs a 6. It's got 2 cells potentially left for it, but this one is blocked by that clue, so the 6 has to sit here. What else is there? Well, now we have a 6 in any of these spots. Not terrifically useful. But we're going to shift back to our unusual thinking. Our unusual thinking in this puzzle had to do with the small number sets. One of the things we've been desperate for is a way to break into the 1 to 4 values, and we marked off that this had a smaller limit because of the 6 being hidden. Let's actually do that now with this clue. It actually is hidden the 6 and the 5, so it has to be a 1 or a 2. And now in this column we've marked as smaller than 1 to 4. We have marked a smaller range of 1 to 2 or 1 to 3 for 3 of the 4 options. There's only one cell left that can be a 4. We've finally broken into the large digits at the top end, so sorry, the small digits at the top end with a 4 clue. If this 4 is actually seeing all buildings, it forces the 5, 6, 7 in this way. Those are all the 6s now in the grid. Those are all the 7s in the grid. I'm expecting I can actually place all of the 5s if I look at it. So let's just check that. There are 4 spots left for the 2 remaining 5s, but if I place a 5 in this cell, this 4 is going to see a building, see a 5, and then see a 7. It's going to be too small. So we can get to here. Now what's going to come about is looks like as step 1 is going to be dealing with this clue. It's seeing a 5, 6, and 7. So the first building seen is going to be larger than the second building seen. And something we haven't marked in is that there's also a greater than constraint on this. So we have a chain of 3 cells that are a decreasing series. So we can actually mark this is a 3 or 4, this is a 2 or 3, this is a 1 or 2. When you can make linkages even across rows and columns like this, very useful to put them in. We now actually have in this column the 1, 2 pair. That gives us a 3. The only cell left in that column that can take a 3. For this to see 4 buildings, it needs a 4 in one of these 2 cells. If a 4 is right here, we're going to see a building, see a 4, and see a 7 with those hidden. So the 4 has to be to the left. We actually place this 4, so we actually now force one option down here. Let's get all of that into the grid. This sees 4 buildings. It's going to be 2, 3, 4, 7. Mark that off. This row needs a 3 and 4 left over. Mark that off. This bottom row needs to have a 4. The only spot left for it is right here. This is going to be a 1, 2, 1, 2 in some order. This group up here needs to see 4 buildings. The only place left for a 4 is this one. It's going to see a 1, and then a 2, and then a 4, and then a 7. That leaves that one in that column. This row now has all but these filled in. Its only option is 1, 2, and 3. The only 4 left in that column is there. It gives a 2. This gives a 3. This space here is a 2. This one wants to see a total of 4 buildings, so it needs to see a building in the spot. So this is the 3, 1, 1, 2. We've gone through to the end. The end got pretty quick, but the critical steps along it were really to break the puzzle into small and large numbers, which you saw with how I was circling, putting squares around some cells on the borders of the grid. And then particularly as we got the 5s, 6s, and 7s placed within the grid through some careful deductions, that would constrain the smaller ranges on this edge. Place digits like this 4 up here, which forces the rest. Place digits like this sort of constraint over there. So a lot of different advanced strategies actually came about in this puzzle, but for sort of a very simple theme and a very fun solve, have to congratulate Tom for a really nice construction. Hope you learned a little something about solving skyscrapers that you didn't know before, and we'll see you again soon.